All right. Hey, everyone. Welcome back to our third series, LinkedIn Live. We got Sandeep Loda, myself, Vivek Panada, and Chris Grove today. So, welcome, Sandeep and Chris. Do you want to say hi as well?
Yeah, absolutely. Thank you, Viv. Great to be doing our third episode of this, like you mentioned. We've been getting a lot of positive feedback and a lot of notes and well wishes. So thank you very much to everyone out there around the world who's been watching us and help spread our messaging. Today, of course, is no different. And we got a really exciting topic today that I feel is also very relevant. We're going to be talking about risk. And risk, of course, to us means many different things. In our world, when we talk about risk, we talk about technical risk, we talk about overall risk, we talk about OT risk, we talk about IT risk, we talk about operational risk, we talk security risk. So this is perfect. We've got one of the riskiest people in the company with us today, Chris Grove, to share a lot of his insights and hopefully help us deconstruct some of this and what it means to Nozomi and Nozomi customers. Thank you for joining us, Chris.
I'm a bit disappointed though. I thought that you guys were on your way over to play a board game of Risk, and I'll settle for this. But I'm very happy to be here. So thank you for inviting me to join you guys' awesome Sandbox.
Awesome. So, to get started, like Sandeep was saying, there's a lot of terminology. When people use the term risk, it's one of those memes where, it doesn't really mean what you think it says, what you're saying, right? So, in fact, Sandeep has a very good anecdote, comparing um, Richter scale and earthquake. So, Sandeep, do you want to elaborate on that thought just a bit about how people think
Absolutely.
about risk differently?
Yeah. Thank you. Thank you. And I was having a conversation 6 months ago or so with an existing customer. We were talking about risk, and we were on completely different pages. And it was confusing me as to how can two or three such bright people and very well schooled in this industry be so disconnected when it comes to risk. And then it kind of hit me. Just like you mentioned, I have a great analogy that involves the Richter scale. So we all know the Richter scale is used for measuring earthquakes. And around the world, it's been standardized upon. So if I talk about an earthquake in Russia or the Middle East or Europe or South America, if I tell you that we just had an earthquake of 3.0 on the Richter scale, every single person on the planet can understand that because we're using the same reference and the same scale and the same standardization. Whereas it's literally the exact opposite today. Some of the problems we're challenged with in cybersecurity. Risk is essentially an arbitrary number, or we may as well be using a random number generator because risk doesn't mean the same thing to each vendor. Risk doesn't mean the same thing to each end user. And risk doesn't mean the same thing within each industry. Therefore, a risk of two for a asset in one part of the world may not be a two in another part of the world. And even within the same industry, two different customers may have the exact same asset doing the exact same thing in a network, but because of the controls that they've placed around it, one may consider this a risk of two, the other one may consider it a risk of seven. And this is the problem with risk today. And Chris has been spending an enormous amount of time with Nozomi to help make this significantly clearer for our customer base. And I think this is a very exciting time for Nozomi to be expanding into this. Chris, maybe I could turn it over to you, if you don't mind, to talk a little bit about some of the things you've been working on in our world.
Sure. Thank you. So I love the analogy on the Richter scale. I was talking to an old colleague who's an expert in risk, and he said the golden rule number one in risk is it has to be a defendable formula. And that's the thing about the Richter scale is you can reproduce that over and over and defend it all day at the university level. You can measure it and you can take that as a metric or a KPI to a board and say, this structure will withstand a certain level, and everyone knows exactly what that level is. And that's exactly what Sandeep was highlighting is very difficult to do when it comes to cyber risk, is get everyone to agree on that level, that common KPI across all of the different parts of a sometimes very complex organization. Also, if you think about the different types of systems that many of our customers may have, for example, think about a smart city. So let's say we pick a risk of 5 Sandeep's example again, what do we do with that in which sector in that smart city? Is it a 5 in the power grid, or is it a 5 in transportation? And then what is the impact, not just the financial impact, but the safety impact of that kind of stuff? The human safety factor comes into play when we're talking about risk as well. So what we've tried to do is wade through a lot of this. We've listened to many of our customers with their challenges and how they want to measure risk. Some of them need to be able to measure risk because of standards, regulations, and you know driving factors like that, best practices as well. So risk management is like baked into best practices. So you really need to be doing that. And what we've done is really listened to how ICS and OT cyber risk management is tracked at like an asset level. What are some of the important things? And we built a system that is going to be released very soon as part of our product that enables the customer. Sorry, it's not going to be released soon. It is out right now. To enable the customer to be able to see risk in a variety of different ways and have an influence over it, because of each sector or each organization within the sector is going to have their own way of doing risk. At the end of the day, there's all of these, FAIR and ISO models, and there's a ton of different ways to standardize on risk, but many organizations take that and depart from it. They use it as a foundation from where to start, and they use their own risk methodology to ensure that they actually track risk according to their needs. So flexibility, being able to speak a common language, being able to feed up to KPIs. These are the types of things that we are addressing with our new asset risk management part of our product. And I can jump into as many details, but take a breath
Yeah,
for a second. I
no,
know
that's
Vivek.
great. Yeah. Yeah. Thank you, Chris. Yeah, oftentimes, when we start with the simple risk equation, right? So you talk about the defendable formula, it gets really creative as you add more and more components to it. When you keep it simple as likelihood times impact, um, a lot of times people get really confused about applying likelihood because, especially in cybersecurity, there's not a lot of statistical data and not a lot of available information to be able to justify some kind of likelihood or probability, right, for certain things to happen. Unlike in safety, where there's quite a bit of available statistical data over hundreds of years. The other piece, which is the impact, is probably a lot easier, especially when you do like cyber PHA, process hazard analysis, combining cybersecurity with it, or some other HAZOP, leverage some other HAZOP for a cyber aspect. You can always figure out the impact. And then finally, adding a component for compensating controls, right? Because if the compensating control can limit impact significantly, then even if the likelihood of certain things to be high is there, the actual effect or actual risk, and the total calculation is going to be a lot lower. But I'm curious. I guess we talked about the different types of risk and how people don't have a yardstick to measure relative to each other. Do you consider, I guess I'm curious in both of your thoughts, do you see going forward people comparing amongst their peers, like within the same industry, or would that be across industries? Because we have different critical infrastructure verticals, power, transportation, oil and gas, and so on and so forth. What, in your opinion, is more relevant? Like, what do people like to see? Is it comparing themselves to someone within the industry or across industries? I guess, Andy, you go first, and then I go to Chris.
Yeah, good question, Viv. Thank you. And I think what you've done is you've kind of brought front row and center what one of the biggest challenges is that we see within the customer base. You and I have witnessed this firsthand. I recall, maybe early this year, late last year, we jumped on a call with a customer of ours. And the first thing this poor guy did is pulled out this spreadsheet with all these complicated formulas. And you almost need a PhD in calculus and statistical mathematics to understand risk score. And some of the formulas and the calculations this poor guy was using, and he told us that that was derived over years of them trying to understand what risk means to their organization. And that's a perfect example of how disconnected even peers within the same industry can be. People tend to be very protective of their risk. And as such, at least for me personally, I've noticed there's a reluctance to share risk formulas, not only within a particular industry or vertical, but certainly within cybersecurity as a whole. Risk is something that is a highly guarded secret within an organization. Of course, protecting the crown jewels is very important, and understanding the vulnerabilities around those crown jewels is even more so important. So the guarding of that information and the formulas to get there, I've noticed, are very protected. So when you talk about sharing, personally, I don't see a lot of sharing aside from generic templates. When it comes to actual customizations, very highly guarded. Chris, I think, sees this from a different lens than we do. So I'd be very curious to hear, Chris, how you feel about that.
Yeah, not too different. We do have a part of our product that is trying to tackle this. As you know, our Vantage product is in the cloud, and customers can choose to opt in to certain levels of working with data, and we can see metrics of stuff, not data, but we're able to see some metrics of things. And we can do comparisons within a sector. The customer chooses what sector they're in, and we can compare a score. You can't see anything anywhere else. It's really obscuring it. It's like you said, it's very protected information. No one, I mean, not even we really know who's got what score. So yeah. And then how that risk is calculated is in itself, not just the score itself, but the formula used is like intellectual property for a lot of these organizations. It's important for them to protect how they do that so that they can use it as a competitive advantage. It is a major advantage when you can weather things like COVID, hurricanes, earthquakes, but other parts of your sector may or may not be as able to do that. So I agree with you 100%, Sandeep.
Great
Yeah, that
answer,
brings a good
Chris.
question. Yeah, thank you, Chris. So we have a couple of questions from the audience. I'm going to put that in the perspective of our discussion. So the first one is, what could small and medium-sized companies that are starting their actions and investments, consider in this space, right? No, to your point, if risk is a closely guarded secret and the calculations are not available outside of independent organizations, especially if they're mature enough to do high-level complex calculations. Um, I guess I'll start with you, Chris, on this. Your thoughts on what could like a medium or a small company that is just starting their cybersecurity journey, should they be focused on um, some level of risk or some calculation of risk or some version of risk management as they start their journey? Because I guess even putting a little more context in it, there are things that we do that people do over time, right? For example, asset inventory, vulnerability identification, threat detection. These are all individual components towards a global cyber risk mitigation or risk management program. So I guess the question coming back to small and medium-sized companies is, where do they start? Like, do they start at this unknown high-level cyber risk management and then dig deeper, or should they be starting on something operational, start with something that as industry's best practice, and then eventually go into their risk management program? Your thoughts on that, please.
Well, that's a complex, it depends answer. I think it's going to depend on pretty much everything. So I think some organizations are going to start with um, tackling a very small problem somewhere, like this attack, I need to mitigate it. So they get a technology, and then they start to expand their horizons a little bit and see more and start to assess more data. They develop more intelligence about things that they have. They get the whole asset inventory built up and everything. And then they go into another level of detail, and then they start doing more and more cybersecurity related things. And at the top of that is the risk management piece, because the risk management is really going to be driven by how accurate the data is that's fed into that algorithm and into that process. So if you start there and you have nothing to work with, there's a lot of investment in adopting a framework that you have no way to leverage. You have no gasoline for that vehicle to make it move forward. So you do really need to have a lot of deep intelligence about how the systems operate, what types of risks are present, how they can be mitigated, are they mitigated? All of this information is going to be needed at some point for whatever risk management framework somebody chooses to embark on. So I think that's, in some organizations, their first step is beginning at the lower level and tackling a problem in the systems and in a detailed state. But then there's other ones where they may have green fields. They may come in and say, look, we're just going to build from day one the right way. We're going to build our organization according to whatever regulations or standards they have, and they're going to move forward from day one, top down risk management, and build processes accordingly. The latter, I think, is a much more expensive approach and more difficult. And it's not very often that organizations have a clean slate to start with and build everything, from scratch. So that's very rare to be able to tackle it that way. So I do think a lot of times it starts in the tools that are being used. It starts in looking at all this data that we now have access to, and having to prove the risk reduction results, being able to prove that the expenses that we paid for the cybersecurity solution are actually producing results. And the measurement of those tools usually bubbles up to risk management. The board, the executives, they need to know how much is the fix going to cost? When we did it actually reduce risk? How much should we spend to reduce what types of risks and where? And again, that's all going to rely on the accuracy of the data that you feed up to those upper level processes.
Super, super. Thanks, Chris. And what you've done is essentially explain to us why there's no easy button today.
Yep.
This is one of the things that we've spent, cybersecurity analysts and researchers can spend a career trying to understand risk. We have an easy button for a lot of other stuff in cybersecurity, but for risk, we don't have a de-risk my network, button sitting in a GUI. And as a result, a lot of this has to be done manually. Another question we got that came in, Chris, and this ties back to actually our very first launch episode that Vivek and I did, where we talked about AI in cybersecurity. One of the challenges we highlighted on that call was how bad actors are using AI offensively against the rest of the world to do things that include poisoning of LLMs and of databases that are used to calculate risk. So one of the questions that just came in from someone was, how can we ensure that AI won't interfere in any way and cause difficulty ensuring that information hasn't been altered or distorted? Of course, critically important to our space. Can you talk a little bit about your experiences and maybe some of the things that we're doing to help prevent those databases from being poisoned?
Yeah, that's a great question. So we have a lot of AI, a lot of generations of AI in our product. We've been using it for over 10 years. Our founders built our product from day one. It's a combination of artificial intelligence and cybersecurity. I think it's important to differentiate between general purpose, like LLM AI, and something that is purpose built. So under the hood and on-prem, we put AI on our own hardware, which is also very difficult to distribute hardware with some AI machine learning technology on it and not leverage the cloud for that. So we've been doing that for a long time. We've had a few other iterations and generations of AI and ML in our product to tackle different problems, different challenges, let's say. When it comes to having a pathway for someone to hit AI in a way that would impact our product, that attack vector doesn't really exist in our product. And it's today, anything we build into it, like if we build a large language model, which we have, it's just coming soon. It's not going to be able to be polluted by somebody attacking it like that. It's going to be an LLM that is purpose built for what it's supposed to do. And it won't be where I can influence your AI model. Everyone's got their own. No one is able to pollute someone else's data. There is no cross interaction between customers. Everyone is in their own segment of everything. Everything is either physically or logically virtually isolated from each other. So there is no opportunity for someone to influence someone else's LLM in Nozomi networks. That doesn't mean that is not a risk for enterprise. There is more and more reliance on different types of AI to do different things, not just do risk, but make other decisions. So I definitely think that could be a problem for those that do not leverage AI in their products carefully in the right way. Definitely a risk to address in the future, but fortunately not directed at us.
Definitely interesting. Kind of expanding on your point about individual data being isolated, right? The other beautiful thing about OT, and as an OT guy, and all of us are OT people in security, we also know that many of these processes are deterministic, right? And the process replicates in a certain way. And if you create the baseline for a certain process and then use machine learning for pattern recognition on something that's anomalous, um, it becomes a much longer game for someone to pollute the data, right? And it becomes a much more intense attack to actually pollute the base data to create a pattern matching issue much further down the road. So I think in certain regards, OT environments are a lot more conducive to machine learning and AI without the risk of some minimal data polluting the whole artifacts, right? Because we have physics to our advantage, right? A certain tank level or a certain refrigeration process, for example, would not work beyond a physical boundary or a process parameter conditions. And so if someone is trying to pollute, they have to also think about physics while they're polluting the data. So just randomly inserting figures or trying to force some values is not going to create the data pollution that they hope to achieve. That would be possible in general purpose IT. So I think that is an advantage in our OT security circles that we can leverage physics to our advantage.
Also, if you look at what is revolutionary around the GPT part of Chat GPT, it's a whole separate topic. Bad data is not bad. It actually reinforces algorithms in many cases. A proper, good, well-built AI model will be able to differentiate the bad data from the good data, and it will help reinforce the algorithm. So it's not as easy. You can't just dump data and expect it to go sideways if it's built properly. And yes, hopefully it's not as easy to influence the operational process as just polluting some AI algorithm in the cloud that would impact a factory or something. Let's hope.
Awesome. We got another couple of questions. Hey, keep them coming, folks. Really appreciate the engagement. So the next one is, obviously you recently we had this massive issue with CrowdStrike updates, and globally many millions of devices are impacted, and indirectly some OT devices too, where it was installed, and directly in some computers. Now, obviously, this could have happened to any particular vendor, so no dissing on an individual company, not on purpose anyway, just so happened to be this one. But the question becomes, obviously, how do you mitigate this type of risk going forward, right? I mean, we're talking about risk today. I have a thought. I'll start off, and maybe Sandeep and Chris, you can add to it. Um, it's one thing for a company to provide guarantees, have a rolling update methodology or validation from their end. It's a totally different ballgame to towards a customer environment where once you receive the update, what you do, you have choices, right? So in the traditional OT sector, we've had long-standing approaches to N-1, N-2 updates, not installing an update as soon as it's available, checking and validating it, like in the NERC world, validating in a representative environment, in a smaller environment before you update all your devices. So we have other options in disaster recovery and business continuity approaches, but I'm curious about your thoughts on what people could do as cloud dependency or updates from vendors increasingly could become a risk for OT environments. Sandeep, you first, perhaps.
Yeah, thanks, Viv. I've got a unique perspective on this. I come from a hardcore network engineering and security engineering background. So for me, it's test, 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 and then test again. You've heard me saying this how many times since you've been in the company? I get on the weekly calls, I address the sales teams, I address the engineering teams, and I tell everybody to bake in lab gear, right? This is one of the reasons why I do that. I've been bit by this since early in my career. 30 years ago, this was still happening. Vendors were still putting out bad patches. It happens, right? No matter what we do, it's still going to happen. I'm sorry to say. That's why I'm such a big proponent for having non production or lab or pre production staging gear for exactly this purpose. Test out updates, test out new features, test out new things that you want to do before you put them into production. N-1 is something that I've lived by, for 30 plus years, since back in the day when I was supporting Cisco networks. right? These are just process related changes that we need to make to be more cautious. Don't be so quick to hit update everything, on Patch Tuesday just because a patch is available. I've been telling people this again for decades. Don't patch just because something's available. You should be patching because there's a business driver or a business need for it. We need new functionality or features out of this patch, or this patch is addressing a serious security flaw, right? So for me, it's all about the process, and ask yourself, do I actually need to do this? Do I need to do it right now? Can we stage this? Can we understand what the impact is? What's the broader scope and impact and implications of us doing this patch? So for me, I mean, I'm pretty firm on that. Again, having been bit by that on more than one occasion by more than one vendor, that's the only lesson you really can take away from it. That's my 2 cents.
Yeah, I'll add, supply chain risks especially are becoming more and more prevalent, and mitigating as best you can, absolutely, first and foremost. However, if you've been in a SOC in any large organization, you know that they're not really, you can't mitigate everything. They are in a constant state of recovery. There's always an incident open. There's always a breach. There's always something to solve. So investing some thought in resiliency, cyber resiliency to these types of incidents is crucial. And doing things like tabletop exercises, going into a post-breach mentality, asking yourself, okay, all of our mitigations failed. It literally happened now. And now what do we do? You figure out real quickly that you need visibility in this part of the system. You need this type of resource. You need these people. You need A, B, C, and D. And ensuring that you're ready for that day is just as important as trying to prevent it in many cases. Being able to recover from a breach is key. And the quicker we can recover, the more competitive we'll be in the marketplace, the more resilient we'll be to outages, safer the world will be. So it's being able to not only prevent these things, but detecting them and then having a clear plan to get to a better state afterwards.
Perfect. Absolutely agreed. Good stuff, guys. As we're coming up to the bottom of the hour here, I think we have time for one more question. And again, thank you, folks. Great questions coming in from the audience. Really appreciate it. Last question here, and this is something we deal with on a regular basis. I think all of us have some good insight and input here. So someone's asking, IoT systems and sensors communicate directly with IT networks. We know this. How do we reduce the risk there? And further to that, does the Purdue model really exist then? Let me start off really quickly. I have to deal with this all the time. I do the designs and the architectures behind this to facilitate safe communication for IoT devices. I would say, to answer the last question, yes, the Purdue model absolutely really does still exist. But what we're looking at now is almost Purdue 2.0, right? Where we've had an evolution of devices and technology that need a different level of connectivity and communication than we needed 10, 20, 30 years ago. So what we're seeing now is an evolution of Purdue. And because there are devices like IoT devices and certain sensors that may or may not need to talk to IT, there's ways that we can safely do that. Several of them come to mind. First off, obviously your traditional access control lists, right? Okay, so this IoT sensor needs to talk to the IT network. What protocols is it using? What ports is it using? What's the source? What's the destination? We can lock that down at layer 2 and layer 3. OSI model layer 2, layer 3, right? We can talk about IPs and MAC addresses. We can lock things down. We can achieve micro-segmentation within segmented zones. So there's a lot of tools and tricks and tips and evolution of our technology that allows us to achieve this safely and securely. Chris, maybe I could turn that over to you quickly, and then we can have Vivek close us off.
Yeah, I agree. The Purdue model does exist. However, it's like a square peg in a round hole. If the Purdue model, for those that don't know, was designed for not security, although we use it for security. It was designed for how close to the process you need to be, how real time access to the data is. If it's millisecond, you're at one level, 0. If it's 1 or more, or whatever the measurement might be in that organization, that's the way these networks are designed. But we came in with our cybersecurity requirements and we said, hey, this is the best thing we have to work with. Let's try to make that work. However, if we had designed that network with cybersecurity first, it would look totally different. We would have looked at how the process works with the humans. We would have created completely different networks, completely different segmentation. So yes, it does exist. We have to use it sometimes, but it's not the optimal way to do security in a network. It might be the optimal way in most cases to do something process engineering, but um, we are moving into a second version of it with cloud, with IoT devices, like you said, jumping layers. Some of them just go 5G straight to the cloud and come in through a completely different avenue. Vibration sensors, for example, there's quite a few of those. So it's changing. The landscape is changing, and the Purdue model, I believe, is being challenged in from multiple fronts, not just from a cybersecurity perspective, but that data access to it. It used to be you could air gap it and you could put it on level 0. Now we have to send it to an AWS cloud. So it's completely different than it used to be.
Yeah, to close it out, given that we're a couple minutes over, I just wanted to highlight the fact that the Purdue model, eventually got merged into the ISA standards, right? The 62443 model that we have. The standards do incorporate the IoT cloud connectivity. So for those of you that are interested in this, the standards have evolved. It's not 20 years old or 30 years old to say this is the only way to consider linearly what needs to talk to the other devices. It's new. So like both Sandeep and Chris were saying, the new connectivity options and the cloud connection from level 0 does change the traditional Purdue model, but it is part of the overall new architecture. So these use cases are not surprising anymore. So with that, folks, it was great chatting as always. Wonderful to have you, Chris, join us. Sandeep, good seeing. And as always, we'll come back next month with another great topic.